We've been looking at different types of graphs and how the information that's on them can actually be misleading. We talked about the reason why people might present misleading graphs as being because they want to bias the information or they want the people seeing the graphs to believe a particular thing. So they change some functions of the graph to make them look the way that they want them to for their purpose. So this graph that we see here is a graph about the average annual snowfall, and you can tell that by looking at the title of the graph. But the bar graph itself is misleading. So if we take a minute here and make the graph bigger, we can see that along the y-axis here we have 6 different Canadian towns, and the bars are meant to represent the average snowfall that each town gets. When we're looking at a graph like this, if we compare, for example, Toronto, which has a very small bar on the graph, and Quebec City, which has a very large bar, it looks like there's a very big discrepancy between how much snow, or a very big difference between how much snow Toronto gets and Quebec City gets. On your screen now, you can see the original graph that we were just looking at with the big difference between Toronto and Quebec City. And you also see a second version of the graph, which looks almost the same. I wanted you to take a minute to look at the two graphs, so the original one that we were looking at here and the new one that I've posted here. And I want you to see if you can figure out what's different about the graph. Alright, so hopefully when you looked at the two graphs, you realize that the bars actually represent the same thing, and they look pretty much the same. The towns down the y-axis are the same, but the x-axis is different. On graph 2, or the new one we've added, we now have intervals along the bottom of the x-axis. An interval is what the graph goes up by. So if we look at the numbers that are along our x-axis, we start at 120, then we go to 160, then 200, then 240, then 280. So if we look at the number pattern between these, we realize that we're actually increasing by 40 each time. So what that means, we're going to blow this up and look at it a little bit more closely. So we have our intervals along the x-axis here, and we've just determined that they go up by 40 each time. But that increase of 40 actually takes 2 spots on the grid. So we can kind of figure out what each spot on the grid, or each box on the grid, represents by looking at our total and dividing it into 2, because there are 2 spots on the grid here. So we have a total in this case of an interval of 40, and it's divided into 2 different grids, which means that each grid mark, or each square on our grid, represents an increase of 20 centimeters. If we go back to comparing the two graphs and we look at Toronto versus Quebec City on the original graph, we look at the fact that Toronto takes up about 1 grid mark, and we look at the fact that Quebec takes up about 11 grid marks, which makes it seem like Quebec City has 11 times as much snow as Toronto. It looks like, we said, like a big difference. Now if we look at the second graph and we look at Toronto versus Quebec City and we pay attention to the intervals on the bottom, it shows that Toronto receives probably about 135 centimeters or so. And remember, we can calculate that by knowing that each grid is an increase of 20. So at this grid mark, we would actually be 140. And as you can see, Toronto comes in slightly below 140. So let's say about 135 centimeters Toronto gets of snow. And then if we look at Quebec City runs in around here, which would be about 320, 340, 340 or 330, 335 we could say, I guess. Let's make that correction. Quebec City gets about 335 centimeters of snow. Now, with this information, what we're doing is we're trying to compare, does Quebec City really get 11 times more snow than Toronto? Well, to figure that out, we can take Toronto's snowfall, which we now know is 135 centimeters, and we can multiply it by 11. So if you punch that into your calculator, you're going to get a total of 1,485 centimeters. So 11 times the snowfall of what Toronto gets is 1,485 centimeters. Quebec City only gets 335 centimeters of snow. That's nowhere near 11 times as much. So what this data is telling us is that Toronto and Quebec City actually have much closer snowfall than is represented by the graph if we don't put a scale on it. So let's talk about how these graphs mislead people. The first graph, graph number 1 over here, because it does not have a scale along the bottom or any point of reference, is very misleading. It makes it look like Quebec City gets almost 10 or 11 times more snow than Toronto does. So if you were just presented with this graph and you looked at it, you would actually think that compared to any of the other towns on here, Toronto gets very little snow, like an almost non-mentionable amount. However, if we look at the other graph, which now has the scale along the bottom in the intervals, you can look at it critically and realize that your scale is only going up by 40 each time, which means that your difference between Toronto's snowfall and Quebec City's snowfall is actually not as great as the difference in the bars makes it seem. So one of the things we have to do when we're looking at graphs is we have to be critical consumers. We can't just look at them and say, oh, Quebec City gets way more than Toronto. Toronto gets almost no snow. If there's a scale or a point of reference in the form of numbers on the bottom, we have to read that and think about it and realize that 135 is not all that different than 335 in the grand scheme of things. Now there's one more version of this graph that I want to look at. Now in this graph, the bars are displayed a little bit differently, even though it's the same information. So take a minute and look, why do Toronto and Quebec City look closer to the amount of snowfall than they did on the last graph? All right, hopefully the first thing you did was you looked at our intervals or our scale along the bottom, and you realized that instead of starting at, I have to go back because I don't remember what it started at. Instead of starting at 120, which it did on graph number 2, and going to 360, our graph actually starts at 0 and goes to 350, and it goes up by intervals of 50 each time instead of 40 each time. So these simple changes, just changing the scale along the bottom, going up by 50 and starting at 0, actually shows a much more even distribution of snow. So when you look at the graph in this way, this is probably the most unbiased version of the graph, because you can look at it and see that, yes, Toronto does get less snow than the other 4 or 5 cities on the list, but it's not significantly less, as both of these two graphs suggest. So just to recap, graphs can be misleading for a number of ways. For example, graph 1 that we looked at was misleading because it didn't have a scale or a point of reference on the bottom. It was just the length of the bars that gave us any information. Even though the bars on graph 2 looked like they were the same length, this graph gave us a little bit more information because at least it had a scale on the bottom. However, the scale that they chose still made it look like there was a very big difference between Toronto and Quebec City because they increased by 40 each time, but because they started at 120 instead of starting at a smaller number or starting at 0. Our third and final graph was the most accurate because it showed the average amount of annual snowfall in terms of all the different cities using a scale of 50 but starting at 0.